Hello people, welcome back to my channel. So today in this video let's learn about random forest. So basically we start with the name itself. So it's a forest that it's an ensemble tree classifiers consisting of different decision trees of different sizes and shapes. So we got the idea about what the forest is there in machine learning. Now what is there the term random? So why it's the term random written before the forest? So there is one reason, or there are two basic components why this forest is called as a random. So first component is that the random sampling of training data when building the trees. So this is where the first randomness comes into picture. So second randomness is the random subset of input features when splitting at nodes. So in order to explain these two randomness, I have considered an example. So this is our original data set. So with this, what you create is you create a bootstrap sample. So one peculiarity of the bootstrap sample is you can have duplicate entries or duplicate observations in that. So as you can see, I've considered 20 instances twice and 20-second instances also twice. So this is where you have the random sampling of the data. Means I've taken any random data in some random fashion. I've considered a bootstrap sample. Second is that the random subset of input feature selection when splitting at the nodes. Now these are the instances or the attributes which you have for this data set or bootstrap sample. So in this you create one instance which has the highest information gain as the root node, and the rest two will become the root nodes or the leaf nodes, which you can say, or the intermediate nodes. So similarly, this decision tree is a resultant of another bootstrap sample, and this decision tree is a resultant of another bootstrap sample. So you can create n number of bootstrap samples and you can create n number of decision trees. So since there is a constraint in this board, so that I have considered only 4 decision trees in that. So now if tomorrow I have an instance to classify, say for example, if tomorrow I have got a record with 24th instance, so this is a ID or the primary key, and you have PQR values. So how this will basically classify? So it employs a majority voting scheme so that the predictions are combined using this voting mechanism. Say if I predict the class label to be positive, and here I predict to be negative and here negative. So you have positive instances is 1 and negative instances are 3. So the majority voting scheme is, according to that, you have negative class as the majority vote. So you classify this as the negative. So this is the randomness of a random forest. So this is a rudimentary analysis of the random forest. Now let's move on to the detail. So why we need to induce this randomization, or why we require to have the randomness in a random forest, or especially in a decision tree. So why? Because if you have the randomness or randomization will make look the decision tree less correlated, so that generalization error of ensemble can be improved. So what less correlated means that if you have 2 decision trees, then the input matching feature or the feature where it matches, it should be less, means it should be less correlated, means they should not look the same. So that makes the tree look different from the another tree. So that is the main thing you have to achieve in random forest. So for that you induce the randomization, and also you can estimate the generalization error, and so it can be improved. Now how the generalization error is given in decision tree? So generalization error is the upper bound, and so you have this equation, that is rho bar 1 minus s square upon s square. Now what rho bar is? It's the average that is correlation of decision trees, and what S square is the strength of tree classifier, means it is called as the margin. Now what margin means? How correctly a particular instance classifies its particular class. So that measure is called as a margin int. So how correctly the class is assigned to a particular instance. So that is called as the margin. Now you can consider this as a framework which we saw in the ensemble method as a base for creating random forest. So we have this original data set. So with original data set we randomize and create some random vectors. Then we use this above graded random vectors to build our decision tree. So we have t number of decision trees. So t is user defined. If you want, you can create up till 100 or 50 or up till any number, that's upon your choice. And based on that you create a number of decision tree, that is tree classifiers. Finally you combine all decision trees. So this is the simple approach that we get from the ensemble method. Now one main thing is that some way you can build the decision tree and some way you can combine all the decision tree, but the main question arises is how to create a random vector. So that vector creation is very crucial in decision trees or in random forests. So for that we have three basic approaches to create a random vector. So the very first approach is called as forest RC. First approach is called as forest RI, that is random input. Say for example you have 100 instances as features. So these are the attributes. So out of this you will be only considering either 10 or 15 or only 20 of these instances, and then you will be building the decision tree completely without any pruning. So what this essentially does is it reduces the bias present in the tree. So this is the main approach in forest RI. So if you want to induce more randomness, what you can do is you can go with bagging. So bagging approach is also used in this in order to increase the randomness. Now there is one thing in this, if you have the input features f, so if it is less, that means your tree is less correlated. So that's the main thing we want to achieve in this. And if your f is more, it means strength of your tree classifier is high. So as you can see, there is a trade-off between increasing the features or decreasing the features. So for that, what you have a regulated input feature which is given by a mathematical equation, f is equal to log to the base 2 d plus 1, where d represents the number of instances or the features. So what advantage it has got is it improves the runtime of your random forest. So this is first approach of creating a random vector. Now second approach is called as forest RC, that is random combination. Say if you have only few instances in D, say you have 10 and you choose only 4 instances, then nowhere you are going to create your decision tree. So that becomes a very difficult thing in this. So what in forest RC you do is you linearly combine the f input features with a uniform distribution into the range -1 to 1. So within this, any value you just combine with the input vectors, that is the features, and you have a new input feature that is called as the L. So this is a linearly combined input feature. Now the third approach what you can have is select one of best F splits. What you did here. So these are the best F splits that you have done. So out of this you need to choose one of the best. So you can do somehow. If you have 10 instances, you can do, but you have 100k or 500k or 1 million instances, then this becomes a difficulty. So, and moreover, it makes the tree look more correlated as compared to Forest RC, and also the runtime saving of this is not that good as compared to Forest RC and Forest RI. So well, that was all regarding the random forest in machine learning. So hope you guys enjoyed this video. If you found you got educated watching this video, please do like, share, comment, and most importantly, don't forget to subscribe to my channel. Thank you very much for watching this video.